Hello everyone, welcome back to the channel. Today let's solve LeetCode problem number 1, to sum. Given an array of numbers and a target value, return the indices of the two numbers that add up to the target. As always, an example is super helpful. Here is the input array, here is the target. The output is going to be 0 and 1, the index is, and the explanation is 1 and 2, these numbers add up to 3, and these are the indexes associated with it. So the approach we're going to take, we're going to use a hash map to store each number's value and its index as we iterate through the array. And for each number, we can calculate the difference, right? The difference is going to be target minus the current number. And in this instance, right, you might think, oh, let's add up 2 and 7 to equal 9, but you can do reverse logic and basically subtract the target from each individual value and then basically like keep track of that. So for each number, we're going to calculate the difference. Difference equals target minus current number. And we're going to then check if the difference exists in the hash map. And if it does, we can return the pair. And I'll show you with the code how we can basically keep track of that and how we're going to return that. But if not, we're going to store the current number and its index in the hash map, and then we're going to continue until the pair is found because it's guaranteed to have a working solution here. So let me pull up an example, and then I'm going to walk you through kind of the approach with building the hash map. Okay. So remember, the hash map is gonna map each number to the index. So as we iterate, the algorithm's gonna look like this. We're gonna be on 1. We're gonna calculate the diff. The diff is gonna be 3 minus each number is gonna be 2. So basically what's gonna happen, we're gonna do 3 minus 1, it's 2. And we're going to check, oh, is 2 in the hash map? No, 2 is not in the hash map. So then let's add this value. And then we're going to continue on the iteration. 2. We're going to calculate the new difference. So 3 minus 2 is 1. And each time we calculate the new difference, we're going to see, oh, is this difference in the hash map? 1. Is 1 in this hash map? Yes. So now we can return, we're gonna find the difference we're gonna use the difference as the key in the hash map and return that value, and also this current index that we're on here. So let's create the hash map for I, n in enumerate nums. This is just a built-in function that's allowing me to get the index and the current number as I iterate through the array. We're going to calculate the diff. Remember, the diff is going to be the target minus n. And then we're going to say if diff in the hash map, we know that's a pair, right? Because instead of adding the numbers, we're doing subtraction to determine if there's a pair. So if diff in the hash map, we're going to return an array that's going to be the hash map diff value in the current index we're on here. And then, of course, building the hash map, right, we need to create it through every iteration. So hash map, we're going to map the number to the index. Okay. So let's run a test case with the code so you can see again how we're building this with the code here. All right. Okay. So we initialize the hash map here. Actually, I'm gonna show you, I'm gonna add this up here just so we can really see where in the code these things are happening. Okay. 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 So initialize the hash map for index, number, and enumerate nums. So I is going to be 0, n is going to be 1. The difference is going to be, so diff equals target, which is 3, minus 1 equals 2. We're going to say, is 2 in the hash map? Is this 2 value in the hash map? No. So then we're going to add the value. So we're going to add 1 mapped to 0. So now 1 is going to be mapped to 0. And then continue on in this iteration here, 2. So it's the first index, and it's the second number. The diff is going to be 3. So difference is going to be target 3 minus n, which is going to be 2. So 3 minus 2 is going to be 1. We're going to say, is 1 in the hash map? Yes, 1 is in the hash map. So now what we can return, we can go to our hash map, key to the difference value, which is going to be 1, and for the first index, it's going to be the value associated here. And then we're going to also return the current index we're on, which is going to be 1. And this is going to return. So now when talking about the time and space complexity, the time is going to be big O of n, because in the worst case, we need to iterate through the entire array once. So in this example, we have to get to this 3 value to return this target of 5, right? Or to return the solution here, because we needed the 2 and the 3. And the space complexity, in the worst case, we're going to store up to n elements in this hash map. So we're building this new hash map structure, and it's going to almost include n elements here. So when thinking about optimization, our current approach uses a hash map, which gives us an efficient solution of linear time and linear space. But a brute force solution, which would be 2 nested loops to check all pairs. And what that solution would look like would be something like this, where we would have 2 pointers. We would have 2 pointers, and we would check each pair. Well, in this situation, or in this example, let's say the target is equal to 6. We would have to check every single pair with a nested loop until we got to 6, so it wouldn't be as efficient. But the space would be constant or bigger of 1, because there's no extra data structure creating to keep track of this, because it's just a 2-pointer approach. So while the brute force method uses less memory, it's much slower, and time efficiency is generally more important, given how cheap memory has become in the modern system. So this approach would be considered the optimal solution here. So I'm going to actually run the code to make sure it works. Oop. What do we got? Oh, should do the trick. Oop. Sorry about that. Let's run it. Green there as well, and the solution works. So thank you for watching, and hope to see you next time.